Well, good afternoon, everyone. Welcome to session 20 of Track C. This afternoon, our speaker is going to be Joe McCarthy. He's the head of sales and operations for SciBite. He has an interesting background. Maybe he'll tell us a little bit about it. He's going to talk today about applying ontologies to enterprise data, lessons learned from life sciences, and applicability to other industries. So that, Joe?
Yeah, great. Thanks a lot, John. Thanks to all of you for coming and for your interest in this topic. I'll start by saying that I feel a little bit out of my element at this conference. I'm neither a CDO nor a technologist. And this is my first time. This is SciBite's first time at this conference. I came with two primary goals in mind. One was to learn about some new technologies, new developments in the data management space, and another was to, hopefully through this talk, bring some value back to this community. I will say that what I'm going to talk about is really life sciences oriented. Everything's through that lens. But I hope that there will be some things that are translatable if you don't happen to be in the life sciences industry as it relates to the applications of standards to your data. For those of you that don't know SciBite, we're a company that was founded about 10 years ago with a mission of developing a set of technologies to help life sciences companies verify their data. And we focus primarily on the I in FAIR, the interoperability bit. I've heard FAIR mentioned a few times this week. I've seen some great talks. Dr. Erlinger talked about the application of FAIR outside of life sciences yesterday. As I was watching these presentations and being exposed to some of these new technologies, I had a tendency to think about where SciBite's logo should fit on some of the slides I was looking at. And depending upon what the orientation of the slides were, SciBite's logo was either going to be on the far left as data is coming into a workflow or into a pipeline, or we're going to be foundational on the bottom. Or when you talk about things like mesh and fabric and all those kinds of things, we were sitting somewhere in the midst of the fabric, potentially applying ontologies and standards in that fabric. So it's been really interesting for me to think about that. So the goal today is to share with you some things that are learnings of ours in life sciences, and how we've used those, the application of ontologies to overcome some of those digital transformation challenges, and hopefully leave you with some thoughts as well that are valuable for you. So big green button. So talking about this all week, talking about this for years, right? The problem is the same for everybody as data expands and scales. You're faced with the issues of ever-increasing wrangling, ever-increasing cleaning, and so you've got to become more efficient in the way that you organize that data so that you can extract, so you can talk about the aspects and features of the data in a shared or a common way, right? So that's nothing new. And these are not going to be new to to any of you either. These are the common challenges. And in the life sciences, as these apply, we're frequently talking to customers who have tons and tons of unstructured data in legacy silos, maybe with different models, maybe different formats. If they're applying standards or ontologies of any kind, frequently it might be competing. They might have, for example, a species list in a LIMS system that's different from a species list they're using in an ELN or an assay registration system. So how do you deal with that? You're also frequently seeing people developing their own taxonomies or their own standards internally. Frequently, those are not mapped to any external ID, and so therefore there's interoperability problems with that. And then where you're seeing metadata being developed around the data, frequently it's not governed very well. Probably similar challenges to what you're all seeing. I like this slide a lot. There are two major issues that we're dealing with at SciBite frequently. One is synonymy, the other is ambiguity. This comes from the EBI, the European Nucleotide Archive, and what they did was they looked at the variety of ways that male was being described in biological samples, and they came up with over 50. So this gives you a sense of the scale of the problem that we're dealing with. And when you look into the public archive in life sciences, this is typical distribution that you'll see. You'll see very few metadata fields that have been normalized, and then you'll see this enormous long tail of fields with tons of variability to them. So solving for that problem is one of the key things that we try to do. I don't think I need that slide to emphasize this point, but this is the other part of it. This is the ambiguity part of it. What I tried to do in this slide was represent life sciences as well as some things that I thought might be relevant outside of my industry. So on the left, you see those either acronyms or those words, and when you see those in text, how do you know what you're talking about? Are you talking about a derivative or something that makes music, in the context of financial services, for example? So these are two of the thorniest issues that we deal with. So what is the value proposition of applying ontologies to your data? Well, if you use ontologies, then you're able to talk about the features and the aspects of your data, the way it's represented in a common shared way, right? Obviously, that makes data interoperable. If you know what you're talking about, if you know what standards you're applying, then your data becomes, by default, more reusable. And in so doing, you can increase data quality by being able to more easily spot issues in the data, errors in the data, inconsistencies in the data. And then perhaps most importantly, you're prepping that data for downstream use. And if you're structuring your data appropriately, you're doing it in a way that lends it to be used in many different ways without having to do further wrangling, further cleaning, further structuring. Obviously, FAIR is the goal. So I mentioned that we talk about FAIR frequently in our business. We focus on the I at SciBite. The other three pillars are very important: findable, accessible, reusable. But if you don't have the interoperability bit, you're really limited in the ways in which you can use your data to apply to a variety of use cases and downstream purposes. So some of the more common things that we work on our customers with in life sciences are knowledge graphs and machine learning. And through the application of interoperability, ontology standards for interoperability, you're facilitating the use of data for machine learning models. You're making those models more robust. It's difficult to do that unless your data has been verified. And then, knowledge graphs plus data, ontologies plus data creates the schema for knowledge graphs. One of the more common ways that our customer base is interrogating their data for new discoveries. So what is an ontology, right? In the classic sense, it's a set of concepts with their features in a specific domain and the relationships of those concepts to others in that same domain. Importantly, they're human generated. It's not one person's view or a small group's view of a specific domain or knowledge area. They represent the community's consensus of knowledge in that domain, and ideally they're machine readable and human readable. And it's something that can be queried and interrogated. This is an effort that's been going on for a long time in the life sciences. The beginnings of this predate the semantic web, but a lot of the things that we refer to as an ontology are not really ontologies, and there's no inherent value judgment in that, because a lot of these things are valuable in the current state that they're in without being a formal expressive ontology. It just depends on the use case, the persona, and the data and the application of that data. But you can start all the way down at the bottom with things as simple as standard term lists in Excel, all the way up through formal expressive ontologies in logic and conveyed in standards like OWL or SCOS, those kinds of things. The issue for our customers is that not all of their data will fit neatly into just one of these things, and so you've got to develop an ontology management and deployment approach that is nimble and flexible enough to deal with the variations that you see here, but also the different data types and the different use cases and business problems that you're trying to solve for. So this is an interesting slide. This is actually a screen grab from our ontology management platform. But what this really is intending to convey here is the importance of identifying entities with a unique ontology ID. So rather than relying on strings for your information, which can inherently be either ambiguous or synonymous, an example would be when you see GSK, are you talking about the protein or the company? When you see BRCA1, are you talking about the gene? If you see BRCA1 and or breast cancer gene 1, are you talking? Those are the same thing, but they're coming back in different strings. And so, if you apply an ontological standard, a unique ID to those things, you can bring those strings, those textual strings, into a common thing with a common understanding. And then that inherently comes with the other benefits of an ontology, which is it's human readable, a definition, and it gives you the association with other things in that same class or subclass. So there are a couple of considerations that we take into account in our engagements. One is retrospective application of ontologies, and the other is prospective. So you can see here representations of some of the common systems and tools our customers use. The vast majority of the data that we're interacting with is in the retrospective category. What you want to do is apply those standards to LIM systems, ELNs, registration systems, even unstructured scientific literature. Semantically enrich those, apply those standards, harmonize them. But then ultimately, you want to set yourself up to avoid recreating those problems. So when you've got new data capture systems, you want to apply those same ontology standards so that someone that's entering new data, whether it be a bench scientist or a clinician or somebody in a different function, they're being guided by those ontology standards with autocomplete or suggestions or autofill so that they're creating data that's born fair and is aligned to the things that you've retrospectively already annotated. So in the life sciences, why use a public ontology? One, because there are so many of them and they're so rich and they've been developed over such a period of time that it makes sense to leverage the knowledge of those communities. But perhaps equally importantly or more importantly, science builds upon itself, maybe in ways that are unique to the life sciences industry. And so if you're using a public ontology and you're mapping your internal data to those public standards, you're building on science by doing that, and you're also perhaps contributing back into the public domain, for future benefit. I wanted to include this because this is kind of the antithesis for interoperability. Certainly standards have been applied here, but none of these things map to each other. And we've all been in airports and upgraded our devices and our cords don't work anymore. And I guess the point is that wherever you need interoperability, you need a common standard to apply, whether it's in life sciences or elsewhere. So I did my best here. I don't know how well I did, but I did my best to grab some ontologies I could find that are in the public domain relevant to other industries. And so perhaps some of these can be applied to the work that some of you are doing. So I've talked about the benefits of ontologies, the benefits of public ontologies, in particular in life sciences. So what are the challenges or what are the struggles with using them? They're not insignificant. And we've kind of teased out the core requirements and the core things to consider when using public ontologies and managing them in your organization. The first is managing change. So public ontologies are not all updated on the same frequency or timelines, if they're updated at all. And you find if you've brought them into your organization, you've deployed them, you're using them in applications, you're constantly chasing those updates to incorporate the relevant ones into your applications and your workflows. Size and scale is an issue. These can be enormous. And in many cases, not all branches are relevant to your work. So you want to try to figure out how to pull the best branches and subclasses from the ontologies that are relevant and leave the bits behind that you don't want to make use of. If you're using them locally, you're going to want subject matter experts contributing into the use of these ontologies, editing them. How do you manage those local changes with changes in the public domain? So you've brought an ontology in, you're using it, you've made some local changes, the public ontology itself changes. You want to bring those changes in without creating breaking changes downstream in the applications that you're using it within. So how do you deal with that? And then governance and access. You want to create a way for ontologies to be used in a democratic way. You want different personas, different experts, different subject matter experts to be able to contribute into these things. But it can't be the Wild West. You've got to have some way of auditing and governing the way that these can be used, modified, edited, deployed, and those kinds of things. And so these speak to some of the things that we've built our technologies to try to address in our domain. It's a great slide in one way. In another way, it's not that great because 10 billion is pretty hard to get your head wrapped around. I mean, this is a study that was done by the European Commission. I believe PwC did this back in 2018. They didn't look just at life sciences R&D data. They looked across the European economy at R&D data. And they determined that lack of fair data in the European economy and R&D costs them 10 billion a year. Okay, there's a real cost there. What does 10 billion mean to me? Honestly, not much. This brings it a little bit closer to home, though, and this is a specific life sciences example. This was done by one of our partners, TetraScience. They went out and they interviewed 500 plus mid-sized pharma execs basically came back with a determination that siloed data, unharmonized data, that sort of thing, costs 1 million hours in productivity a year and $100 million in productivity that could be spent, on new discoveries. I don't think I'll share that metric. What I'll talk about in the next 2 slides are 2 use cases. This is one of the more common use cases. I can speak to this because Takeda we've presented publicly together on this multiple times, but this is kind of a standard registration use case that we've done with Takeda. So they, like many of our customers, came to us with multiple different siloed data sets from multiple legacy registration systems, none of which were harmonized, none of which could be searched easily. It led to cost in search time, but also more importantly, deduplication of experiments because they didn't know what they'd done, they couldn't find it. They were also creating a new front end for the capture of new information for registration data, and they had to marry those up. And so, as I was referring to before, we did the legacy harmonization, and we helped them with the application of new ontologies for the prospective data capture. Different use case, similar theme. Pfizer was searching across their ELN, but they were using 3 different data models to do it, 3 different models in the same domain. And so we worked with them on synonym expansion through the application of standards. And you can see the data there, 53% increase in the hit rate once they did that synonym expansion based on those standards. So kind of back to the beginning, right? These are the challenges I talked about. I mean, the goal for us at SciBite, as I mentioned at the beginning, the mission for us was to help our customers verify their data, maximize and leverage that data as an asset, as a revenue driver, but most importantly, as a faster means to innovation and knowledge discovery for the development of therapies, drugs, vaccines for all of our benefit. And so, hopefully, as I mentioned, some of these themes can be applied in the work that you're all doing to try to bring standards to your organizations. So I think that's my last slide. That's me done. I'll stop there and take questions if there are any.
Thank you. Good presentation. We do similar work with ontologies ourselves, and so I'm +1 for the thinking style and the way to do it. There was 3 ontologies I wanted to make sure people are aware of that weren't on your slide. So the first is QUDT.org. This came out of NASA. It's quantities, units, and data types. Really, really good for units of measure. So if you've got any kind of engineering data, so you can all agree what a barrel of oil is and things like that. So that's QUDT. PermID.org. I helped build when I was at Thomson Reuters. I saw you were there as well once upon a time. That's organizations and people and some financial instruments. Again, all open data. And then I'm with S&P Global now, and we've just started to release some of our ontologies. So they're at dunl.org, DUNL.org.
Great. Thanks for sharing that.
Yeah.
What else?
Thanks, John. Well, while we're on the sharing list, I've been working on a standard ISO 8000, and that's exactly what this was designed for. And the origin of that was in 2008, starting putting the NATO catalogs, which covers all of this, into an e-commerce system. And there's lots of standards. You can check it up, ISO 8000, part 100, 200, and that's progressing. But the big thing there is the concept identifiers. And to the concept identifiers with the definitions, tools that's doing that, multiple languages, the cases that we had is Russian and something is blue. You cannot translate it because there's no word like blue in Russia. It's dark blue or light blue, but you have to choose, et cetera, et cetera.
Right.
So just for that's worth.
Interesting. Thank you.
First, thank you for that very interesting talk. And I have a question because we also have developed ontologies, of course, and what we stumbled over was finding existing ontologies. You pointed out the importance of reusing them. How did you tackle this challenge?
Thanks for the question. So one thing that I didn't say about SciBite is that we were based on the campus of the EBI in Hingston, Cambridge, and we were founded by scientists from Pfizer who developed our stack. And we've, fortunately, because of where we're based, we've been able to pull a lot of those ontologists from the European Bioinformatics Institute. So they come with all the domain knowledge with them. And you know, the ontologies that I've referred to in life sciences that we use most frequently in the public domain are things that we've pulled into our platform and then make them available to our customers, you know, through the platform with essentially a one-click load. But there's a wealth of, you know, over 100, for example, in our platform can be one-click loaded. So there's a wealth of ontologies to be leveraged in life sciences. I'm not sure if that addressed your question, though, Dr. Erlinger.
Thanks. So yes, for your domain, do you have a recommendation for other domains?
That's why I mentioned that this would be through the lens of life sciences, right? That's where our domain expertise is. Our platforms, our tooling is agnostic, but it's going to take a domain expert, someone with knowledge of the industry, of the standards that exist in the industry to bring those into the platform. That's kind of where we stop.
Yeah. Great, thanks.
Yeah, sure.
About 10 years ago, I spent a lot of time with ontologies in agricultural research to organize research publications and data and so on. Use cases primarily being around discoverability. And I'm curious now, you know, with the rise of machine learning and using, you know, machine learning classifiers, how do you see ontologies and machine learning coming together?
It's a good question. I mean, we do a lot of the work that we do is augmented. We do use machine learning methods to augment our vocabularies and our ontologies that we use and then deploy. The question that I am not prepared to answer honestly is what's going to be the impact of LLMs on this? I think that we're in a pretty good position given the base that we've got to be able to leverage those technologies, but it's moving so fast. We've got to get out in front of that, to be honest with you, and think about the ways to apply those things to make this more robust than it is today. But we do use machine learning methods as it is now to augment what we have.
I don't think anyone can speak.
It's for people.
Oh, it's people. Thank you for the presentation. So 2 questions. One, in the data architecture, where do you see ontologies fit? Is it more like a data product? Like, I'm just kind of curious where it sits. And then second, outside of R&D in life sciences, like let's say commercial or manufacturing, where else do you see use cases for ontologies?
So with regard to the first question, I mentioned, you know, I was trying to picture where our tooling would sit in some of the presentations I'd seen earlier. We always think about the application of these standards as foundational. So you start with your data, you determine which data sets need to be standardized, you determine which standards to apply or which ontologies to apply, and then you apply those standards, you enrich the data, and then from there it's really up to you in terms of where you want that data to flow. What is the downstream use? Is it going into a data product? Is it being incorporated into a data mesh? Are you trying to line it up or marry it with different data sets, different standards? So we talk about ourselves as being a semantic stack, a foundational stack. So on the entry side, you know, before you want to make use of it. With respect to the second question, it kind of goes back to my answer to Dr. Erlinger, which is I need somebody in a domain to tell me what they want to see in the way of applying these ontology standards in their industry. I mean, we're experts in the life sciences and the use of these ontologies with scientific data, less so once you get outside of that. So.
I have a couple of questions online. I think you answered the first one, exploring LLMs to map ontologies. They also ask, do you use standard ontologies for your customers, or do your customers choose which ontologies to standardize for?
It's a good question. It's both. Depending upon the use case and the data set in question, our curation team will provide some guidance on the right ontologies to use. but frequently our customers as domain experts have their own ideas about what they want to use for standards on their own data. And so we'll work with them to augment those standards, maybe align them to a public standard so that there's a mix of both there in most cases.
Okay. Someone had a question back there.
Perhaps a little bit like piggybacking on your remark also. So what I see at the moment in the German automotive industry, for instance, there's a strong also movement to use ontologies also for organizing obviously data, also research data or like R&D in a way. And but the key question is, how does it align with the standard data models that are also being used in the more traditional databases? And so introducing the semantic layer comes with a lot of power, but also many open questions. So I don't know, what is your suggestion, or are you concerned by this?
I'm not concerned by it. It does introduce, things that you need to work through for sure. What we have found in life sciences is that if you apply the right standard to the right data set for the right use case, the right business problem, the other issues essentially take care of themselves, so long as you're doing it at the beginning of the process, at the beginning of the pipeline, and not somewhere along the way. That's been our experience.
So two observations of how we try and solve for that. The first is you can always add another column into your data within the physical store and put the URI of the thing that you're referring to with a string in the column next to it, right? So it's that things not strings idea. You put that URI in there, it's only 200 characters or whatever, but put it in there, and now it's traveling along with the data. The second thing you can do is the column has a name in the database. There's a few databases that allow you to attach tags to those columns, and so you could use the tag to attach the type, the ontological type, or you can always use the comment field. No one ever uses the comment field in the data dictionary, so stick the URI in the comment field, and then you're enriching the data in the original schema, rather than trying to do it late. To your point, doing it later, and then it's hard to keep up.
10 years from now, you can use NLP to parse the comment.
Was it you that mentioned the missing ontologies on this? Who? Yeah. Well, one of the online people said, can someone type the 3 ontologies that an attendee mentioned? So you type it in the chat. Yeah. Someone else? Have time for one more question.
Thank you for a great presentation. How would you use the agile way to show value faster? So how long was this ontology project at any of the clients? And CFOs don't want to wait for a year. They want to see something in 6 months. So how would you go about implementation?
Most of our implementations begin with a POC, a small slice, and then you prove the merits of that project, and then you expand it to the full data set. Typically, our POCs start 2 to 3 months, and then roll into the development of the production application from there. Most of the deployments that we do are less than a year. Some are a little bit longer, that are a little bit more complex, involve more elements of our stack, but most of it's pretty quick to deploy. Our tooling's all API first. It's very fast. It's lightweight. It's meant to be plugged in. It's agnostic to different technologies. I mentioned data mesh and TetraScience, and we've got a pretty robust partner ecosystem. So we try to allow these technologies to be deployed by our customers in the environments that they want, with the out-of-the-box or homegrown tooling that they prefer to use.
Well, Joe, thank you so much for your presentation.
Great, thank you.